We have learnt in our first unit that geometry is the field of mathematics that addresses spatial sense and geometric reasoning. Our learners only begin to understand geometry through direct interaction with their physical world. Although geometry is an integral part of our intermediate phase curriculum, many of our learners fail to develop a deeper understanding of basic geometric concepts before they enter the senior phase. When teaching in Montessori schools, a husband and wife team of Dutch mathematics educators, Pierre and Dina van Hiele, noticed difficulties that their learners experience when trying to learn geometry. They observed that the difference in the level of thinking required when going from primary to secondary school was very demanding for learners who had not yet grasped the basic concepts. These observations led them to develop a model involving 5 levels of geometric reasoning through which a learner passes when learning, from being able to recognize a figure to finally writing a formal geometric proof. The Van Hieles believed that writing proofs requires reasoning at a much higher level, and therefore learners need to have more experience in thinking at lower levels before learning formal geometric concepts. The Van Hiele model consists of 5 levels of thinking processes, and learners must develop mastery at each level before they are able to progress to the next. Progression from one level to the next is best facilitated through strategically planned instruction. According to Van Hiele, the attainment of the new level cannot be affected by teaching, but still by a suitable choice of exercises. The teacher can create a situation for the learner favorable to the attainment of the higher level of thinking. Geometry instruction in your classroom should therefore be designed with the following levels in mind. Visual. The learner should be able to describe shapes on the basis of their appearance. Analysis. The learner should be able to describe shapes on the basis of their properties. Abstraction. The learner should be able to recognize the importance of properties and the relationships among them, which assist learners in logically ordering the properties of the shapes. Deduction. At this level, the learner should be able to attain logical reasoning ability and prove theorems deductively. Rigor. Here the learner should be able to establish and analyze different theorems in different postulation systems. When planning geometry lessons, intermediate phase teachers should provide their learners with experiences that will help them progress only through the first 3 levels of this model. Learners progress through levels 4 and 5 in the secondary school. In addition to providing the descriptions of reasoning specific to each level of geometry, the Van Hieles also made statements that help characterize their model. These statements are especially useful for the teacher who intends to apply this model into his or her teaching methods. Levels are sequential. In order to move above a level, learners must progress through previous levels. Learners need to acquire the thinking strategies of the previous level in order to function successfully at the next level. Advancement. The progress from one level to the next is dependent on the content and methods of instruction given, rather than age. Intrinsic and extrinsic. The inherent objects at one level become the objects of study at the next level. Mismatch. The vocabulary used in instruction has to be on par with the learner's levels of communication. Otherwise, the lack of communication will cause the learner to struggle with objects of thought that have not been understood at the previous level, and instead may lead to rote learning and only temporary success at the present level. The Van Heeler model also includes the 5-phase framework, which consists of appropriate teaching instructions to guide learning through each of the levels. Phase 1, information. Learners develop vocabulary and concepts for a particular task. The teacher assesses a learner's interpretation and reasoning and determines how to move forward with future tasks. Phase 2, directed orientation. Learners actively engage in teacher-directed tasks. They work with the developments from the previous stage to gain an understanding of them, as well as connections among them. Phase 3, explication. Learners are given the opportunity to verbalize their understanding. The teacher leads the discussion. Phase 4, free orientation. Learners are challenged with tasks that are more complex and discover their own way of completing each task. Phase 5, integration. Learners summarize what they have learned, so creating an overview of the concept at hand. Teachers can identify the developmental level of each of the learners in the classroom by allowing the learners to do a simple activity. This activity serves as a tool to determine each learner's geometric level and thus inform instruction in the classroom. Create a worksheet consisting of triangles of varying size and classification and allow your learners to complete the task as follows. Classification of triangles. Sort the triangles into as many different groups as you possibly can. Write a paragraph describing why you placed each of the triangles into a particular group. Use the information from the activity to determine the developmental level based on the following divisions. Intermediate phase teachers must be aware that learners should be progressing towards level 3 with very few or none at level 4. Once the developmental levels of the learners in your class have been determined, you should then be able to determine the instructional level. Learners taught at their instructional level master skills necessary for them to progress in geometric reasoning. It is very important to keep in mind that if a learner is at one developmental level and you instruct concepts at a different level, it will be more likely that the learner will not understand or retain the information. The Van Heeler model of geometric reasoning and the phases of learning provide a framework for effective instruction. Teachers must provide learners with interesting activities that draw on well-structured instruction and purposeful interaction among learners to promote deep understanding of geometric concepts. The activities must not only benefit learners, but also enhance our skills as mathematics teachers.